Now what about limits on floating point numbers? Just like there are an infinite number of integers, there are of course an infinite number of real numbers. Floats are a way to approximate real numbers. But just like we cannot represent all possible integers, we cannot represent all possible real numbers. So any calculation that we do that results in a real number, like for example 3 true division 2, that will be approximated using a float. So if I imagine the number line, which is infinite in both directions, the middle of that is 0, the real number 0. And it turns out I can precisely represent the real number 0 as a float. 0.0 truly is the real number 0. But as we have seen on this system, the maximum representable float is around 1.8 times 10 to the power 308. And of course, there are an infinite number of real numbers beyond that. I simply cannot represent those on this system. Now the same thing happens on the negative side. So minus 1.8 times 10 to the power 308 is the most negative I can represent. And once again, I cannot represent any numbers beyond that. Now, what about numbers close to 0? It turns out if you read the sys.float info very carefully, it tells you that the smallest positive float that can be represented is very close to 0, but there's a bit of a gap, because the smallest positive number that can be represented is, roughly speaking, 2.2 times 10 to the minus 308. So that's a very, very small magnitude number. It is positive, but there's a tiny gap between 0 and that. So for example, half of this number, which is roughly 1.1 times 10 to the power minus 308, that number cannot be represented. So there are gaps in the real number line. Only some of the points along this infinite continuum can actually be represented. So this is a very, very important point, because it leads to all kinds of strange and sometimes disastrous errors when we write code that deals with real numbers. Many real numbers cannot be represented precisely as floats in Python. And since many other programming languages use essentially the same representation that Python does, this floating point representation, many of these challenges carry over to other programming languages. So just to give you a small illustration of this, if I have the real number 0.1, so 1 true division 10, that internally is represented as a fraction that is very close to 0.1, but it's not exactly correct. Take a look at these numbers very carefully. You'll see that this ends with 6397. This is the same number ending with 63968. If it ended with 63970, that would be a denominator that is exactly 10 times larger than the numerator, and that would of course be 1 over 10. But we can't represent that precisely. And so this ratio is the nearest approximation to this real number. So anytime we are doing calculations in Python that involve floating point numbers, please remember that we are actually working with approximate values. And because of that, all kinds of errors can creep in. Here is a quick example. If I take 0.1, the float, and I multiply it with 3, I of course expect 0.3. But if I use this operator, which we haven't yet seen, which checks for equality, if I check if this expression is equal to this floating point value, it tells me the answer is false. What? Why is 0.1 times 3 not equal to 0.3? Well, let's explore this and other things in the Python REPL.